In this last video, we're going to be looking at the effect of a catalyst on the chemical reaction. So we're going to see the elephant toothpaste demonstration, and this is one that you may not try at home. It uses very concentrated hydrogen peroxide, so gloves must be worn. And you can use the catalyst potassium iodide to generate oxygen gas and water vapor from this very exothermic reaction. Exothermic means heat is released, so we'll see the water that's produced will start to boil, and we'll test the properties of the gas that's produced. So I'm adding hydrogen peroxide. You guys can tell me, do you see a lot of bubbles being formed from the reaction?
No.
There's a few from me pouring it, but there generally aren't a ton of bubbles. The hydrogen peroxide will decompose on its own to form water and the gas oxygen. So it's just happening so slowly that we don't see any bubbles. So I'm going to capture the bubbles that I form in this soap solution. It's still not happening very fast, so what we're going to do is speed up the reaction using a catalyst. So this particular catalyst is saturated potassium iodide. So this, when I add it, is going to have a reaction speed up. And we'll see a lot more bubble formation. So we're going to test whether this actually forms oxygen gas using a splint test or just a piece of burnt paper. So oxygen is one of the reagents for combustion. So it will support combustion. And if I insert that burnt out splint, it actually reignites in that oxygen atmosphere. So it'll keep doing that until the paper gets wet from the bubbles, which is what happened that time. Another catalyst for hydrogen peroxide decomposition is manganese dioxide, MnO2. This is another reaction that you may not try at home. It uses the catalyst inserted into this tea bag, and when you open the cork, it drops into the hydrogen peroxide and you get a reaction. So here we're again using the fact that it's an exothermic reaction to produce steam, which looks like a genie coming out of the bottle. And if we rotate it, you can see that there's a very large column of steam coming out of this reaction. So the catalyst increased the rate of reaction, and we formed not only oxygen gas, but visible water vapor from the exothermic reaction where heat was released. And that concludes our celebration of National Chemistry Week. Remember to visit the UPJ Chemistry Society Instagram page for at-home instructions for many of these demonstrations, as well as future activities.